Okay, welcome to Chemistry Tutoring with Mr. Schmidt. And so we are going over some of the problems that are found in the notes and how to solve those. You can find these in the PowerPoint that are attached to the, or in our Google Drive, or in our Google Classroom rather. So with that, let's go ahead and get started. What we're going to first do is let me fix my marker here. Okay, so now what we're going to first do is we're going to set up our problem with how many molecules of carbon dioxide are in 4.56 moles of carbon dioxide. One thing that we should know already is that when we have 1 mole of any substance, that is going to be equal to 6.02 times 10 to the 23rd. And so we can set up conversion factors based off of this equivalent statement. We can say that 1 mole of something is equal to 6.02 times 10 to the 23rd. And we can make a conversion from this because this expression equals 1 because they're equal values. We can also say that we have 6.02 times 10 to the 23rd, and we can say that equals 1 mole. And this expression equals 1 as well. So when we make a conversion, we're not changing anything. We're simply multiplying by 1, just in this form. And so whenever we have a problem, we always start with what is given, what is provided. And so we're provided with 4.56 moles, and we're wanting to go to molecules. So we're going to be going from moles to molecules. And in order to go from moles to molecules, we're going to use our equivalent statement that we provided here with saying 1 mole is equal to 6.02 times 10 to the 23rd. So you begin your bracket 4.56 moles. And this is of CO2, carbon dioxide, as we should properly name that. And so anytime we have the unit up here, we're going to have the same unit down here. So we're going from moles of CO2. And then we're able to go from moles right to molecules. So this is going to go to molecules. And of CO2 as well. And molecules is the representative unit of CO2 because carbon dioxide is a molecule. We know carbon dioxide is a molecule by name. We see that prefix dioxide, di meaning 2. Anytime we're using those prefixes, we have a molecule. So our representative particle of CO2, both nonmetals, is going to be a molecule. So we know that 1 mole is going to be equal to 6.02 times 10 to the 23rd. And so we have now found how many molecules. We're at molecules of CO2, so we know to stop right there. We don't need to go any further with our bracket. And so all we have to do is simply, in this case, multiply, because what we're going to divide is by 1, and we don't need to put that in our calculator. So multiply the top of the bracket, and you should come out with something close to 2.75 times 10 to the 24th. And this is going to be molecules of CO2. All right, on to the next one. Here we want to know how many moles of water we have if we have this many molecules of water. And notice this is less than our expression up here, 1 mole, so we should have less than 1 mole as our answer, some number less than 1. So try to use some analytical skills here when we're looking at these problems so that you can see if your answer makes sense. So the first thing we do once again is we use the value that we are given, and that is 5.87 times 10 to the 22, and this is molecules of H2O. That's a 2. Don't ask me about it. And then we know that we're using the same expression. 1 mole is equal to 6.02 times 10 to the 23rd, and we could use either one of these. We have to use the one that best applies. Well, we'll know this when we look at our bracket. Molecules of H2O, this should be molecules of H2O. And this then is moles of H2O. So we're going to use the one in which mole is in the numerator. 1 mole is equal to 6.02 times 10 to the 23rd. And now all this is a simple division problem. And when you put this in your calculator, make sure that you put this value in parentheses. Otherwise, it will give you an order of operations error, and you will not get the correct answer. And so our answer should come to 0.0975. This will be moles. MOL is the abbreviation for moles of H2O. All right, and with that, we see that our answer is less than 1. It does make sense, and so we can be satisfied that that's probably the correct answer. Also, we notice that our units cancel here, and we're left with moles of H2O, which is what we're trying to seek. All right, now we can go to the next problem. This one is a little bit different because now this is asking us how many atoms of carbon are in 1.23 moles of this molecule. And this molecule is glucose. And so we can't go from moles to atoms when we have a molecule. We have to go to mole. Then we have to break that down into its representative particle because this is a molecule or a molecular compound. We have to break that into a molecule. And then from a molecule, we can break that into an atoms. And so we know that when we have 1 mole, this equals 6.02 times 10 to the 23rd of whatever. And so here we'd have 1 mole would be equal to 1 mole would be equal to 6.02 times 10 to the 23rd. And then we have molecules to atoms. And if we look at this molecule, we can see the number of atoms of each type. And in particular, 1 molecule of this glucose, C6H12O6, is equal to 6 atoms of carbon. And I'm getting that 6 from right there. And so once again, we can say we have 1 molecule is equal to 6 atoms. So we just plug this into a bracket. So we start with the number that's given, 1.23 moles of C6H12O6. We know that 1 mole of this C6H12O6 is equal to 6.02 times 10 to the 23rd molecules of C6H12O6. And then we also know that 1 molecule C6H12O6 is equal to 6 atoms of carbon. And so what we should get there is some answer close to this, 4.44 times 10 to the 24th. And this is of carbon atoms. So we always want to make sure we express our unit and also the substance, compound, element, whatever it is that you're looking for in the answer. In this case, it's carbon atoms, not just atoms, but carbon atoms. And then on this last part for our notes, it says how many moles is 7.78 times 10 to the 24th formula units of magnesium chloride. We should recognize magnesium chloride as an ionic compound. And so if it's ionic, what we then know is that the representative particle is the formula unit. And that's why they're asking formula units versus molecules. We can't say molecules, how many molecules you have, because they don't have any molecules for MgCl2 or magnesium chloride. We have formula units because it's an ionic compound. And so once again, this is just as simple as conversion using we can go from moles directly to formula units. And formula units, and so we know that 1 mole is equal to 6.02 times 10 to the 23rd formula units. So we start our bracket with 7.78 times 10 to the 24th. Formula units, form U of MgCl2, and we know that 6.02 times 10 to the 23rd formula units of MgCl2 is equal to 1 mole of MgCl2. Now, before you put this in your calculator, notice this number is much larger than a mole, so our answer should be greater than 1. And in this case, it is greater than 1. It should be 12.9 moles of MgCl2. All right, and these last two problems are very similar to the homework that I sent home. So hopefully this will help you if you're watching. As we know, 15 minutes could save you 15% or more on your next quiz exam. So we have how many moles of calcium are in 3.12 times 10 to the 21 atoms of calcium. So calcium is an element, and the representative particle for an element is an atom. So we can go from moles directly to atoms in this case because we are dealing with an element. Back when we were dealing with the molecule glucose, that was a molecule, so we had to go from moles to molecules, then to atoms. But because calcium is an element, its representative particle is an atom, so we can go right from moles to atoms. And so in this case, we have 3.12 times 10 to the 24th atoms, and this is of Ca, and we know that 6.02 times 10 to the 23rd atoms of Ca is equal to 1 mole of calcium. And once again, you can see this number is larger than this number, so our answer should be greater than 1. And so, oh, I'm sorry, that's not true. This is a 21. Whoops. Let me erase it. 21. Now, this number is smaller than this number. I wrote it down 24. Notice it's a 21 there. So this number is smaller, so our answer should be less than 1. And if you calculate that out, our answer should be 0.00518 moles of calcium. And our answer is less than 1, so that makes sense. And then last but not least, we have how many molecules are there in 5.1 moles of oxygen? Remember, oxygen is a diatomic molecule, so its formula is O2. And so we're going to go from moles of O2 to molecules. And notice we're going to molecules, not atoms, because oxygen is a molecule. So if we wanted to see how many oxygen atoms, we'd have to go from moles to molecules, then to atoms. But we're only asked to stop at molecules, so we'll stop there. So we know that 1 mole of O2 is equal to 6.02 times 10 to the 23rd molecules. And so we just set up this conversion. Start with what's given, 5.1 moles of O2. We know that 1 mole of O2, notice the units are the same, is equal to 6.02 times 10 to the 23rd molecules of O2. And so when you multiply that out, you should get something close to 3.07 times 10 to the 24th molecules of O2. All right, that takes us to the 15-minute mark. I hope you enjoyed this video. Hopefully it helps. Thank you for watching.